And now I am screencastifying. Woohoo! Am I presenting?
No.
I thought I clicked it. There we go. Okay. All right. Today we put a number to what our eyeballs were looking at yesterday. But before we do that, taking a look at this homework assignment, you just had to put some things to write for part 2. I don't care if you write out the sentences I did, but you need to put more than just the word treatment for explanatory. It should be the type of treatment. Or you can put surgery or radiation, because that's a choice. The response variable is survival time. Let's hope it's in months and years and not like days and seconds and hours, because that would be a little bit sad. And the explanatory variable is categorical, and the response variable is survival time. So that would not be part of linear regression, because we don't, I mean, it wouldn't be graphed as linear regression. It would be graphed as a bar chart or a segmented bar chart. So make sure for I want our specific sentences for number 8A. 8A should start off with the phrase, this scatter plot displays. And I also want our sentence somewhat, I guess, not really for number 9, because it's broken up into 3 pieces. So for 10B should be the scatter plot displays. And I probably could have put a little bit more detail into that one. And I think I did on the one, oh, I know where it is. On the one you're grading, I mean, on the one you're using to grade, there is more detail on that one. And I can show you right here. If I go to this and go down to homework answers, number 10 does have more detail than what I have up here. It says strong positive linear association between female body mass measured in kilograms and metabolic rate measured in calories for men and women who are subjects of a study of dieting. So that was your graph for number 10, and then number 11 has some questions. So I would like at least one question about this homework assignment. Anybody have anything that they thought of, want to know more about? Thank you, Ella. 12 is covered. Sorry, I didn't uncover it before I uploaded it. So this would be the answer to 12. Thank you. That's a good question. Does the same overall pattern hold for men and women? I said the same general pattern seems to hold for males. It's positive linear, but if you just look at the red dots, which I think are these, putting an ellipse around those red dots would make it wider than putting an ellipse around the black dots. Agreed? The red seems to not be quite as strongly associated. That's my opinion. Questions? Any other question? All right, tomorrow we're participating in a game that technically can be worldwide, but for some reason your Chromebooks do not allow your names to go on the world list like mine does. My Chromebook and my desk computer allow it. There's some setting that notes on your Chromebooks, I don't know. But bring your Chromebooks tomorrow, please. And the homework over the weekend, I think, is nothing. If you are done with the notes, which brings me to my other thing I have to announce. So let's see, here we are. Oh, October, you have to get down to October. There we go. It says end of, oh, there's 4 questions for homework, but you don't have the big notes. So as soon as you're done with doing all of the guided notes for packet pages 6 through 8, I'm only collecting them electronically from everybody. So as soon as you're done, and I know who you are because I looked, Sam needed to upload his. Trent, somehow yours did not get uploaded with your animal to the correct spot, and neither did Liz's, or Alex, or Max, because he wasn't here. Everybody else, I believe, Molly, Bella, Ben, Maria, Julia, Zach, Jenna, and Ella, you guys all had like the whole assignment done, right? Yeah. Okay, and there's probably going to be some time tomorrow if you want to get your assignment done in class to do that. So is that correct, Sam, Trent, Liz? That you didn't have your notes uploaded to with your animal on it, and now they are? Yes. Trent, yes? No. Where are you supposed to put it? You're supposed to put it right here. You only have one of these 3 showing up. That one. See, that probably would be you right there. Let's check it out. There it is. All right. These people that say done late, you're not done late. Is that good, Trent? Is that enough help? Okay. All right. So that's where it goes, and you guys only have one link. Alex, your link is going to be where it usually is, though, okay, hon? It's going to be down under the virtual homework answers and corrections. So when you get to that. All righty. Questions on the assignment? Anybody at home, questions on the assignment? All right. So today we're going to do correlation. Make sure that assignment at home, you guys post it, and here you guys should stick this assignment into your green folders. Please, again, double check your little graphs. Make sure there's a title, a label, and axis numbers. 3.9, do you guys understand what I meant when I said perhaps it's piecewise linear? It doesn't really look like this is very close to linear. That looks like it's like an inverse square or hyperbola. This looks like it could be linear from here. So it looks like the graph is actually 2 different pieces for number 9. And then the other graph you had were these birds. And I don't know if you understood exactly what was happening with these birds that are apparently sparrowhawks. Basically, they have a family, and that family flies together down south and then returns up north. And if some of the older members of the family can't make it or they pass away, then they allow new birds into their family. But if only like a couple birds don't make it back from the south, a couple birds are too old, you don't have as many new birds joining. So that's what this is. The more birds that return with the colony, the fewer new birds are allowed to join their group or their cult or their brood, I guess would be what it's called. And we'll be doing more with the sparrowhawks this evening. Okay, so, we need a pulse person and a temperature taker. I might be the temperature taker if nobody wants to do that. You guys at home, if you have somewhere a thermometer you can do. This data, I'm not taking it till I get people in trouble and find out if you should or should not be here. I won't even look at it. I'll just press it and let you see it so you can write it down. But I need somebody to remind us to take our pulses, but we need to take our pulses after we've been sitting for a while. So this is your paper. I don't think we'll get, whoops, I'm sorry. I don't think we'll get the first column even filled out, but just in case. So we're gonna take our pulse. And of course, you guys at home, I forgot to put this as an upload for you. So I will do that. If you want to add the date, so you guys at home, I will put this as a PDF and I will show you where I will put it. Right now, you can just write this down somewhere and keep the data handy. So Jenna, Zach, and Alex, I will put this under here, daily class videos. I will add it right to this link. All right, and it will say pulse and temperature. I don't know that I can do that right now. I guess I probably can. Let's see, temperature, pulse and temperature. I just saw it. There we go. So you guys in the classroom, if you put your neck up and turn your neck like to the door, you can probably feel it right there. And we'll take it for 15 seconds and multiply by 4. Make sure everybody, you guys try to find it while I'm doing this stuff. Oh, you do. I know I do. It's faster than blazes. Okay, electronic PDF assignments and PDF. So yeah, don't cause yourself to have a stroke or something just because. All right. Yeah, a good teacher would have had this done already. I'm not claiming to be a good teacher today. Okay, so I'm going to put this in worksheets. So, oh, what the heck did I do? All right, you guys at home do not have to print this out right now. You can take your pulse with us and print this out later today. Or you can just use a slip of paper and not even print this out. I don't care. You just need a table. One says pulse and one says temperature. And this is what we're going to do with it. So I'm going to put today's date right here for me. And it is October 21, I believe. Okay, so you guys at home, do you all have your pulse? Have you all found it? Okay, I'm going to say 3, 2, 1, and then you just count until I say stop. Everybody here have it? Okay. We're going to take it in 3, 2, 1. stop. Okay, whatever you counted, multiply by 4. Because we only did it for 15 seconds. Hi.
Well, you got like
Is that good for today? No, that's okay. Thank you.
Okay.
Maybe during class you can do another one and then there's only one left.
I mean, generally, athletes go the same amount.
All right, that was pretty good for me. I don't know, I think I did it wrong because I usually don't have such a low pulse. But we're gonna go with it. So my pulse was 72 because it was 18. So you guys put what your pulse was. And then I'm gonna come around and take your temperature. All you do, like I would pass this around, but that's frowned upon unless we sanitize. So I'm at 97.6. And we'll use this data. So I will come around and take your temperatures. You guys at home, if you have a way to take your temperature, try to do it soon. And if you can't do it soon, find your pulse before you take your temperature, like do your pulse again. So it's a pair. Some of you guys have a phone. My Samsung phone used to, I could put my finger on the picture thing and go like this, and it would find my pulse for me. But my Pixel 3 doesn't do that. So I don't know if iPhones do that. Do you have a fitness app and your iPhone takes your pulse? If you have an iWatch and it takes your pulse or some type of gadget, you can use that. All right? Okay, so we started this venture yesterday up on that step. Well, now he's not connected. And we moved down to this step. Today we're going to kind of just get at the beginning of this. We're going to talk about R today. It's the pirate's favorite statistic, the correlation coefficient. Are you ready, you mateys? Did we miss Pirate Day in September? Isn't it in September? Talk Like a Pirate Day? Or is that like still coming up in October? Because whoever did announcements should have done it with a piratical nonsense. Somebody look up when it's Talk Like a Pirate Day. It's in the fall.
September 19th.
Oh, we missed it. That wasn't when you were doing it, was it? Could have been.
Maybe.
I should have told you. Okay. So now we have done the top 3 objectives, identify the form, direction, and strength of the relationship. But we hopefully noticed that yesterday sometimes our eyeballs can tell if it's weak or strong. Sometimes it's questionable, but we actually can put a number to this. It's called the correlation coefficient. We will not be calculating the correlation coefficient by hand because it is a doozy. The little secretary in our calculator is busy. What do we want to call the secretary in our calculator? I was just going to say we could call it Busy Lizzie, but we have a Liz, and so I don't want to like. Who?
Barb.
Barb?
Barb.
No.
Like Marv?
It's like a secretary name. No.
We named her Janice, 4th block. Do you guys have a name you want for the secretary? All right. I should call him Norman. A normal curve. Norman Allen is our secretary. All right, we're going to interpret the correlation. We're going to start understanding the basic properties of correlation, and we are going to use technology. Explain why association does not imply causation. We've talked about this a little bit already. There are some things that are highly correlated, like it is true that as the years march on, so as the Earth gets older, we've had less pirates. If you plot the year, like 2020, versus how many pirates are sailing the seven seas, and you go backwards, like in the 1800s, there were a lot of pirates, and then as it got closer to the 1900, there were less pirates, and now that we're like in the 2020s, there's even less pirates out there. So what's causing that to happen? It's not really, as the Earth getting older, pirates are getting fewer, but what is the confounding variable lurking in the background there? There's a couple of them. Why don't we have the pirates sailing the seven seas? In fact, anybody that's ever vacationed at Topsail, North Carolina, it's called Topsail, but they pronounce it Topsail, because Blackbeard used to sail his ship into the harbor and hide it from people, but if you looked up in the sky, you could see his top sail still. So, why don't we have as many pirates? What's going on there? What's changed as the Earth has gotten older that would cause the pirates to go away?
There's not as much treasure.
The treasure's all getting found. Supposedly there's Blackbeard's treasure buried somewhere in Topsail and it's sunk. You could ask Mrs. Gano, because her father has a house on Topsail, and there's the old legend that somewhere sunken in Topsail Island is Blackbeard's treasure. I think it was Blackbeard. I don't know. What else is going on? Think. Technology. Boats can radio for help now, and airplanes and helicopters can come and, kind of like the movie with Tom Hanks. What was that called? I watched it 2 years ago. I forget where his ship, something happened to the motor and the guys came on and Captain Phillips, I think was his name, went with them, but then the Navy rescued him or something, and he saved the guys on his ship. They threw the glass down, so the pirates walking around in their bare feet got their feet cut and they could trace where they were going. Was it called Captain Phillips? Ben's looking it up. Yes?
Yes.
All right. Let me know when you find out.
It is.
All right. It's called Captain Phillips, but I don't remember. That was the last time pirates were famous, I think, was when they captured that ship. Okay. This scatter plot displays a negative correlation, right? A negative slope. And it's, I don't know, if you ellipse this guy up, it's kind of big. But now what if we reveal that there's more up there? Well, now the trend is positive, and it almost looks a little bit stronger because it's a longer, thinner ellipse. So, on page 20, we have some information. You don't have this. We don't call it high, we call it strong and weak. But you can see the difference between, here's a 0.9, here's a perfect correlation. Here's an interesting thing. To have, even if the dots aren't in perfect alignment, you can have a 1 or a -1 correlation. And you'll see that tomorrow. So you can see a 0 correlation looks like a snowstorm. We're going to see some other 0 correlations that might be a bit surprising. -0.5, here's -0.9, and we don't call these low and high, we call them weak and strong. This is not exactly like your graph, but it's close. And then we have all these facts. R is always a number between -1 and +1. -1 meaning you're sloping downhill like a line. +1 uphill. If R is positive, the slope will be positive. If R is negative, the slope will be negative. Values near 0 indicate a very weak linear relationship. Not necessarily a snowstorm, it could look something else. The strength of the relationship grows stronger as you move out from 0. So 0 to 1, this is strong. As you move in, you're getting weak. And the same thing happens here. Down here to -1, you get to strong. And as you're going this way, you go back to weak. So when you're near 0, it's weak. And then this says the extreme values of -1 and +1 only occur in a case of a perfect linear relationship. That is in theory. Theory. We'll see tomorrow in our game that you can have a +1 and for sure the dots don't look like they're perfectly lined up. But that's due to rounding. Okay, this is what you have in your notes. So I would like you to draw the ellipses around all of those. See how close 0.999 is? It's not a perfect straight line. So there's a lot of things that affect these. Like down here in this -0.7, this dot up here actually is going to make the relationship probably stronger than it really is. And that's a special type of outlier that we'll be learning more about. This is page 20. So page 21 is blank. We're going to move right along to page 22. This is the formula for the correlation coefficient right here. Do you have to memorize that formula? Only if you want a bonus point. So only if you want a bonus point do you have to remember this formula. And it's actually not that difficult. Let me show you how I do it. I remember that it has to be divided by n minus 1, or that's the coefficient. And then I'm going to sum up the z-scores of x times the z-scores of y. Because that's what those two things are after the summation sign, right? But you don't get a bonus point for putting that down, and you don't get half a bonus point. To get the full bonus point, you have to say to yourself, how do I find z-score of x? Take x minus its mean divided by its standard deviation. How do I find z-score of y? I take y minus its mean divided by its standard deviation. And then put this back out front, and that will get you a couple bonus points because you're going to have a quiz on the formulas a couple times. What formulas, you say, Mrs. Garrett? Well, if you go to that sheet that we highlighted yesterday, you can see the 15-point bonus or 15-point quiz that we'll be taking this chapter. Last chapter was the empirical rule one. And this chapter for you guys, if you go to that Cliff Notes thing, I'm showing you on the screen. You go to this Cliff Notes thing, the thing we'll eventually be having a quiz on is on the back. It's filled out for you on the back, and I'm going to discuss it all, just not today. And we're only getting started with it. We don't have the whole thing. We're not close to taking those quizzes yet. That will happen at the end of next week. Okay, so let's look at all of the little details. We're on page 21 now. So remember that this is really the z-scores of the x's, and this is really the z-scores of the y's, the standard scores. So let's make sure we understand what each of these letters are in here. What's n represent? Small n. That's why I was being picky-dicky about capital N's on your normal curves. The notation, a small n represents what? The number of what? Number of data pieces. How many data points do you have? 10, then it will go from x of 1, x of 2, x of 3, x of 4, up to x of 10. And all the x sub 1s are paired with the y sub 1, x sub 2 is paired with y sub 2. So what x sub I means is it is an x-axis coordinate. Like 6, 10 might be x sub 2, and that would be y sub 2. So what is y sub I? It is, why does x always feel like it has to start with and, but then y you would say a?
That happens with a lot of them. Just like street letters.
I guess because, well, y sometimes can be a vowel. I don't know. Doesn't it feel weird to say and y-axis coordinate? So I can't do that. I have to say a. I guess we could say a x-axis coordinate. Whatever you want to do. This is not English class, Mrs. Garrett. Just don't worry about it. What's x bar represent? Yeah, the mean of all the x values, right? The average mean of all x coordinates. So what we did is in chapter 1 and chapter 2, we did single variable data. And now we're doing 2 variable data. So sometimes instead of being called 2 variable data, it's called bivariate data. And y bar is the mean of all the y coordinates. And s sub x is the what? Standard deviation of the x values. And that is how much an x value typically varies from x bar, right? We've learned that sentence. And s sub y is the standard deviation of the y values. So when we ask our calculator to calculate this correlation coefficient, it's doing a buttload of work, right? I mean, even if my data set was only like 3, 8, 7, 12, and 8, 19. These are all the x's, these are all the y's. So the first thing the calculator, Norman, our secretary Norman, has to do is add up those. That adds up to 18. The x's all sum up to 18. Then you would have to do 18 divided by 3 to get x bar, which is 6. Then you would have to say, okay, 3 minus 6 is negative 3. 7 minus 6 is 1. 8 minus 6 is 2. Square those off, 9, 1, 4. Add those up, 14. Divide that by 3 minus 2. Take the square root to get the s of x. Then you would have to come back and take that s of x value and find the z-scores of all the x's. So he would have to do 3 minus 6 divided by s of x plus 7 minus 6 divided by s of x plus 8 minus 6 divided by s of x. Actually, that's not what he does, because this has to get multiplied by whatever the 8 minus the y bar is. And then you add that to the 7 minus the 6 divided by s of x times the 12 minus the y bar divided by s of y. So can you imagine if there were more than 3 data points, how long this is going to take him? Not very long, because he's a calculator and he has a microchip for a brain, but it's kind of like when we talked about the normal probability plot. There's a lot going on to calculate R. That's why we didn't talk about it yesterday. You don't have to calculate it. You just have to know how to push the buttons to make Norman calculate it. If you don't like Norman as our secretary, then you're gonna have to come up with a new name. All right, but that's what we're doing. Okay. I didn't mean for you to write all that down. What are important facts about the correlation coefficient? Well, the biggest fact about the correlation coefficient is it's using X bar, it's using 2 means, and it's using 2 standard deviations, and they are both what? What kind of measures are they? Begins, it's like a dash word. Non-resistant. It's using 4 non-resistant measures to calculate itself, so guess what R is? Most important fact, correlation coefficient is very much affected by deviant points, by outliers. Tremendously affected by outliers. So that's the first fact I want you to record. I think it's here somewhere. Where is it? Oh, it's not there. Oh no. Okay, let me go back here. So these facts, the biggest thing I want you to remember is R, the correlation coefficient, is very, extremely non-resistant to outliers. And we actually have 3 different types of outliers. We have those ones we haven't written down yet. High leverage points. What else are they called? Let me see, what were they in your notes? High leverage points. I got this. Influential points and outliers. There's 3 different types. All right. If R is positive, the slope of our line will be positive. If R is negative, the slope will be negative. And R is used in other calculations. R is used to calculate R squared, which is called the coefficient of determination, which I think you took notes on, or will be taking notes on tonight if you haven't finished. So R squared is also non-resistant. And there's a bunch of other things that we'll explore, but R does not equal the slope, but it's used in the calculation of the slope. So maybe we should write that one down. R does not equal, and I apologize, I didn't do this. The statisticians did not get together with mathematicians when they came up with the equation of the linear regression line. The equation of the linear regression line is y equals ax plus, bx plus a plus bx. B is the slope in statistics class. And I apologize because in algebra class you've learned mx plus b your whole life. Well, now b is not the intercept, it's the slope. So while r doesn't equal b, R is used in a calculation. I believe B equals R times S of Y over S of X. That's what you have written down, isn't it? It's been a minute since I taught this. On number 3 with your 3.2 guided notes, that's it, isn't it? Pretty confident that it is. All right. So just a couple more things. We are now going to turn to page 22. R doesn't really help us out that much in telling us how good is this relationship. That's R square's job. All R does is tell us how close are the little duckies waddling behind mommy duck. Are they perfect? Then it would be a -1. So I'm gonna here's an example of a -1. +1, here's an example of a +1. But R equals 0 can be quite tricky. This is what we think of by default. When R equals 0, we think, hey, we're looking at a snowstorm. Or somebody sneezed. It's splattered all over. But R represents linear. R represents, I can spell represents. A linear pattern. How well something fits a linear pattern. So if you had something like this, I'll draw an XY axis coordinate for us. This pattern would also give you, that would be R equals 0 in your calculator. A parabola is curving, it would give you an R equals 0. You could also have a circle, that would equal 0. You could have, now interestingly enough, an exponential won't give you an R equals 0. You don't have to write this down, but if you had something that looked like this, if you had a pattern that looked like this, you're going to get an R. You're going to get a line through there. The calculator will try to do it because the calculator is blind to the vision. That's why we need the human eyeballs with the calculator's calculations, because the calculator isn't really as smart as us. All right. Another thing that would give you an R equals 0 would be something like this. Who knows what that is? What's that a graph of? A couple different things. Did you really not have this at all in Algebra 2 anymore?
I just don't like the
Sine or cosine? It's sine or cosine, right? It's a trigonometric function. So this is a periodic function. It's either sine or cosine. It could be both because they're just 90-degree translations of each other. So that's what R equals 0 is all about. But then we have two exceptions. So that's what we're going to do next. Does anybody have any questions so far? This is a day of all the little pieces parts of R equals, of what R is. All right. There are two exceptions to perfect lines. So these are two linear exceptions. Please draw in yourself a X and Y axis coordinate. And then go over to 4 on the x-axis and put in some dots. If you had a data experiment and it came up with that as your answers, that does not have an R equal to 1, even though it's a perfect straight line. Can anybody see why? If I calculated R here, it would not equal 1 or -1 if I drew the line through those dots. Does anybody know what that R is going to equal? It would be 0. Why do you think so, Max?
Because it's not like spreading.
It's not spreading it's not spreading left and right. But mathematically, can anybody see why that's gonna be, this is gonna be an R equals 0. Anybody see why? I don't know what's under here. And that I'm gonna have to change. Does anybody see why that happens mathematically? This is going to be, there we go. Well, let's take a couple points. I'm gonna make a t-chart, x comma y. This point up here, that would be 4 comma what, perhaps? Over 4 up 6. Let's use up 6. And this point right here is over 4 up 0, and that point down there would be like over 4 down 2, right? What is the average of my x values there? They're all 4. What's the standard deviation of my x values here? They don't vary at all, Mrs. Garrett. They don't vary from their mean. They are all the mean. So what's the standard deviation? 0. If you take these values and go up to this equation, do you see a conundrum? This is all going to be 4 minus 4 divided by 0. Can you do that? No, but the numerator's 0. So the statisticians had to say, oh my gosh, you can't calculate this mathematically. Let's just say that there's no linear relationship there. But it's perfect linear relationship. Perfect linear relationship, but doesn't help you at all. As the x's go back and forth, does it help you predict what the y's are going to be? X is always 4, and y is going from positive infinity to negative infinity. This does 0 to help us. So that's why they pick 0. Because linear regression is all about this. In chapter 1, you only had one set of data. So you had to add it up and find the mean and find its standard deviation, and that's all you could use to make predictions, like we did with the normal curve. If we then found out that our data set is normally distributed, then we could make all kinds of predictions. This chapter, it says, okay, wait a minute. I have an X data set, but now it's paired with a Y. How much does the X help me predict the Y? Because I didn't have a Y back in chapter 1 and 2, but now I do. So how much does it help me with my predicting of what X is going to be? This helps 0. And likewise with a vertical line, if I put a vertical line in, or I'm sorry, if I put a horizontal line in at 7, so if I put like a dot here and here and here, run my line through there, do this. So that's, let's say, -3, 7, 0, 7, and 4, 7. All my y bars are going to equal 7. My s of y is equal to 0. And if I take that up into here, I'm going to have 7 minus 7 over 0 for each of my points, and that's a conundrum also. So the statistician said, well, we're going to let that be 0 also. Because now, how good are the x's at predicting y is equal to 7? Well, the best predictor of y is just to find the mean and the standard deviation of y. If you know the mean of y is 7 and the standard deviation is 0, then you would be able to say, I don't need x's to tell me what's going on. Everybody's a 7 in this y set. So these are 2 exceptions to the linear rule. Horizontal and vertical lines are exceptions. And instead of having a correlation of 1 or -1, they have a correlation of 0. And now you know all about R. Aren't you feeling so much more enriched than usual? Not really, Mrs. Garrett. Okay, so now we're going to use R. So we need our generic example packet. We're going to add to it a brief bit. We're on page 3 now. This is what we did yesterday, and this is for Max. Yesterday, Max, we took this bottom equation and we highlighted it, so that's why you need your highlighters. We highlighted this, not equation, it's a sentence. There it is. We highlighted that sentence, and then we drew a line under the words "this scatter plot displays A" and the association between. And we talked about how for the word strength, you're going to substitute either strong or weak. For the word direction, you're going to substitute positive or negative. We just don't use neither, and it's not on, if you're looking at page 2 right now, it's not on, this is the thin little thing that was in your, take that out.
Oh.
So I'm showing you what we did to page 2. Our form is either going to be linear or curved. We're not going to use specific, because if you look at this, if I gave you this, you can't say, well, that's parabolic or that's exponential, because it could be that the other piece that you're missing goes like this, that'd be exponential. It could be like that, which would be quadratic or an even power, or it could go off like that, which would be a cubic or an odd power function. So we either say linear or curved. If it's curving, we don't say it's exponential. We just say curved. So that's what we did yesterday right there. Okay? We're going to fill out 3 and 4 today. So you guys at home still with us? We're almost done, actually, sort of. Okay, so before I show you how to calculate R, did you get everything you needed? Okay. Let's go to page 3. This is page 3. It says take the R value from the linear regression screen and report it on the line below. So I'm going to show you how to calculate it here in a minute. And this is what all the packet pages look like. You're going to put a 2-digit number in here. So I want you to always round to the 100, unless otherwise directed. And then R verifies what we saw with our eyeballs. So the sentence is almost the same. Instead of saying this scatter plot displays, we're going to say the correlation coefficient, and then you're going to write in the number. And then you're going to say verifies the, and then these words you have to sub in for. Substitute appropriate words. And then we're also going to say association between. And then we're going to do minimal context today. M-I-N-I. So we really overdid the context yesterday, and because of that, we don't have to overdo it today. And then if you are a picky dicky and like the details, then I'm on page 4, which is part of this page, going to help you with what a textbook, I found this in a textbook, how they discuss R. Okay? So, here we are on this part. And again, this is only an opinion. College professors, AP, they might have a different opinion, but this is the best one I can come up with to help us out here. And I just noticed this was like all hanging down here, and it's driving me crazy. So, put that back up. This is my ear exam. Oh, okay. I didn't want you to leave it. Okay. So, let's start with weak. Weak is close to what number? 0. So anything in here I would describe as very weak. In fact, if you are under 5 or -5, if you are if you're higher than -5 but lower than 5, this is the weak. That's the weak area. So from 0.5 to 0.7, and from this is moderately strong, less than strong. Okay. This is moderate, moderately strong. This is also moderately strong, but in a negative direction, which is a different adjective for a different part of the sentence. And then from -0.7 to -0.9, I'd call that strong. Same thing up here. Oops, did it wrong. About that. So here would be the strong. And thus, anything above 0.9 and higher, or -0.9 and lower, this would be my very strong. Now, yesterday I said I don't really care too much about the varies and the moderately. As long as you can get in between -0.5 and 0.5 is weak, and anything out of that is approaching very strong, or strong to very strong, and then I'm good with that. But there is a caution here. Depending on the situation, a close to 0 correlation can be considered pretty important, pretty strong. And we will talk about what happened when the Space Shuttle Challenger took off, and that had NASA and Morton Thiokol had a statistician in the room when the decision was made to fly those astronauts off into space. Does anybody remember why that was an important space shuttle, other than the fact that it blew up? Why was it such a big deal, that space shuttle liftoff? It was a big deal because when I first started teaching statistics in 2000, the year 2000, so that was 20 years ago, I can subtract. I had kids in my classroom that would actually almost start crying when we talked about this, because they remembered watching this takeoff, because it was the takeoff that had the teacher on board. Remember, they put out this big search for a civilian to come take off in the space shuttle with all the astronauts. And a lady named Christy McCullough, who was a science teacher, won. And it was such a huge deal because there was a national contest throughout the country to take an elementary school science project. She was in charge of these science projects. So kids all across the country competed to have an elementary science project and a middle school science project and a high school science project taken up into the space shuttle for her to conduct. That was one of her jobs. And within 10 seconds off after liftoff, have you guys seen the video? It blows up and it forms this U shape because of the rocket. Okay, well, we're gonna watch that. All right. Any questions on that? Now we're gonna figure out how to find R. All right, so we're gonna go back to this that we did yesterday in our packet. So we're looking at page 12 in our packet. We filled out this for it yesterday, although it was in handwriting and not in such, and we don't have the line through there yet, but we will. I don't care. I just gave people those in case, because you're going to take that out every day and you're going to need it. Like right now, don't put it away. Because we're gonna use that when we do the bottom. Okay, so we did part 1 and part 2 yesterday. Today we're gonna fill in part 3, the correlation coefficient and the explanation of it. So if I'm using this sentence right here, I can start at the very bottom of page 12, I can start my sentence. And you shouldn't misspell this because it's right here for you. The correlation coefficient, and I'm going to put the number in there that I'm going to calculate in my calculator in a minute, verifies the, what did we call this yesterday? Look up at your scatter plot description. Was it strong negative or strong positive? Was it linear or curved? What did we say? Moderately strong, positive, linear, association between, and now we can be minimalists, body, right? Body, and I'm just going to put LBS, body pounds, and back pounds. So yesterday, I'm coming back to this, I promise. Yesterday we put, for context, we put between body weight in pounds and backpack weight in pounds of 9th grade students at Webb School who are going on a backpacking trip. We put something like that in for context yesterday. Since we did such a fantastic job at that, now I can do context down to just those words. All right, everybody ready? There's a couple ways to do this. I'm going to teach you the way that I ultimately want you to do it. So here we go. In your calculator, make sure everything's cleared out. Hit Y equal, make sure there's nothing there. If there is, clear it out. I'm going to start from scratch. So I want you to do second Y equals, turn on plot 1. We don't want sprint and long jump in there. That was the second thing we did. I want to go back to body. And I want to go to cap. So clear out long J and put in cap. That's what we did yesterday. Oh, you guys probably don't have sprint and long jump. You probably have had Mass F and Met F, because that's the last one you guys did. Okay. Some of you may have learned this in algebra class. You may have learned to go stat, calculate, and choose limreg right here. We're not doing it that way. And I want to make sure everybody can hit zoom 9 and get that picture again. So Max, that's how we got this picture, except for in a second the line's going to come through. And then to get those numbers around the window, we just hit window. Okay. Do you have your calculator?
It's actually in my locker. I need it.
Where's your locker?
It's right there.
Well, go get it. All right, and the rest of us, I'll be right with you. I just want to make sure my neighbor has arrived. Her power went out with the storm this morning, and so I wanted to make sure. Okay. We are going to go to a button that we use a heck of a lot in AP Stat. but we only use it right now for this. And tomorrow, there's really not a whole lot of me talking. You guys get to play that game. You guys at home doing okay? Yes? Okay. Max is getting his calculator. What's the over and under on Mr. Keene remembering his calculator today? Patrick? Anybody know Patrick?
Yeah, I can probably forget the other day.
He didn't walk into school with a backpack today.
He what?
He didn't walk into school with a backpack today.
Huh?
Yeah, I don't think he takes anything home.
No, probably not.
Probably not. All right, so open up that calculator. Do hit y equals, see if there's anything there. Do second y equals. Pick the first scatter plot. Now put in clear, second list, down to body. There's a whole lot here. So do alpha and B is yeah. Oh, you don't have it ungrouped yet. Should I send you the group? No. Okay, so I will get that for you shortly. Where'd my yellow calculator go? Oh, where is the calculator? I didn't take it home. Somebody borrowing my yellow calculator?
That's it.
Yep, I lent it out to somebody yesterday and they did not return it to my desk.
Yeah, so,
Okay, I will get this into your calculator. Okay. And then once you're here, I like the plus sign better than the dot. So hit zoom 9 and see if you can get this. Yeah? Okay, here we go. Ready? After you have this picture and you've put it down on your paper and written this, like eventually we're going to do this packet the whole way through, not with this data set, but with different data sets. Everybody hit stat and go over to tests. And you want the one on the very bottom. So go up arrow to Linreg t-test. All right, hit enter. Put in your lists, which our list is second list alpha B for body. And then second list alpha 8 for pack. Frequency should say 1. I don't care what this next line says. I don't care what it has. But this reg equation, we're going to put this in, and then you won't have to change it for a while. So hit clear. So the only thing you have to remember right now is stat over to test up to Linreg t-test. Linreg t-test. Okay? Max, question?
Yeah, the link selector, you have
You don't have, I don't think you do, I don't know. I thought I don't know how you not select them. I guess, yeah. I don't know, it might give you, okay. We want Norman to calculate this equation and stick it on the graph for us. So that's what this is for. And we want him to plot it on Y1, which when I hit Y1 here, you don't have to do that. The rate equations, the secretary's going to copy it right in there for me. So this is how this is done. To get the rate equation here, and we already looked at this a little bit, we want a variable. So see the bars right beside the clear? This you don't have to remember tonight, because once we put it in there, it will stay there for you. We want a y variable, right? So go over to y bars, and we want a function, and we want y1. So now that that y1's there, it won't change. It will always be there for you. Go down and hit calculate.
What's the bar spot?
It's by clear. Here, I'll do the whole thing from scratch. Ready? Go to stat, over to test, up arrow to linreg t-test. You put in your list like normal. Make sure frequency says 1. To get y1 in there, you hit bars, which is right beside the clear button. We want a y variable, so I have to go over to y bars and then just hit function because we want it to say y1. A line is a function, and then hit enter. And that gets the y1 in there, and now you don't have to remember that for like until late next week. Okay, go down and hit calculate. And on this part of the screen, there's nothing that we want. But if you arrow down, you will see R at the bottom, 0.7946. I'll come help you. So that's what we put in this. 0.79, it was 0.7946, so it's 0.79 goes right here. Is a 0.7 give us moderately strong? I have to go back to my Cliff Notes to check that out. So let's go back to the Cliff Notes. Anything above 0.7 to 0.9, we're right on the borderline of cutoff of moderately strong to strong. So we're good. Our eyeballs did us well yesterday. What happens if your eyeballs see it wrong? Well, then you can go back and change the first sentence. I mean, this is the numerical version. Okay, Julia? Okay, stat, test, linreg t-test. You didn't put in the new list. You have to put in, because there's nothing in L1 right now. That's why it's giving me an error. There's nothing in L2, so I have to put in pack.
On these slides.
And now it will do it for you. And see, you can see more than we did. There it is. Okay, last one. Let's do this again for sprint and long jump. So this is in our big packet, page 16. Yesterday we did this part. All right, here we go. In our calculators, everybody at page 16. First, I'm going to hit clear, and then this is pretty important. If I hit y equals, there's something in there now, because I asked Norman to put it in there for me. Oh, before we do anything else, if you hit graph now, see how the line comes in? And I guess what we should do, although we can do this next time, technically we can go back to page 12 and we can now sketch that line through that point and that point. So you could go back here now and you could say, okay, the line went through that point and that point, so there's my line. That's what you should have on your backpack, page 12, before we get rid of that. Okay, ready to do sprint? On page 16, right? This is page 16. Okay. Hit y equals and clear that equation out because it's not going to have anything to do with this new data set. Hit second y equals. Change body to what? Spit. Second list alpha S. Natural log. All the way down to SP. There he is. And take out pack and put in long J, which is the closed parentheses. And now you should hit zoom 9, and it should look like the picture. You know what? Zoom 9 looks like that picture we have on our paper. Okay, the new stuff, how do we get there? What button do you have to remember tonight? And if you don't remember it, you're gonna have to go to this recording and go all the way to the end of the recording because we don't have it written down. Stat, tests, up arrow to liberate t-test. Notice everything's set up for you except for the wrong data list, right? So stat, test, up arrow to liberate t-test. Take out body, put in spint again. Take out pack, put in long J. Y1 should still be there. That's the nice thing about this one. Hit calculate. Now, before I arrow down, yesterday we said it was a strong negative linear. So I'm hoping this is like a negative above 7. And then I got it. So let's see what it was. Negative 0.838. So, right here, we're going to put negative 0.838 would make that 3 become a what? 8.4. And then we'd have to write our sentence. But I think we can say that for tomorrow, because I know you guys want to get going. And what about A skips, Mrs. Garrett? There's only one tonight. It's number 22. You have a lot of multiple choice, so it should go quickly. Hang on, and I'll let you take a picture. Multiple choice starts with 27. So you only have, all of these, I think, are multiple choice, maybe not this last one. So use the partial credit multiple choice. And if you want to do the assignment that's over the weekend, you already know how to do all that, because we're not learning anything new. Well, how do you find that? On the calendar. I'll send a remind that lets you guys know what I just said, in case, because this assignment's not going to take you that long. And if you really don't want to have any homework over the weekend, get your notes finished, which is just a couple of you. I don't know, Liz and Sam, did you have your notes all done?
Yeah.
So you have to still do your notes. And Bella, before you leave, I have a question to ask you. And then I'll show Matt. Oh, no, okay. Yeah. Yeah. Okay. All right. I need. I don't need this one. This was the. And see you guys. Sorry, you guys can go. Unless you have questions. All right. Bye bye. This was the classwork page. We have 8 to 9. But I don't have yeah. That was page 39. And I've already, yeah, he did 1, 2, 3 class. And then this was the worksheet number 3, page 42 and 43. And we did a homework assignment. Right now, I only have 4 out of 20.
I was like, everything I have is.
Yes.
Can I have one of those sheets, like, to fill out for
Yes. So,
Well, both choice is very quick and easy.
no, that's already.
And just like
This is part of it.
Oh, the month.
And literally half of all those.
That was the review. That's the other thing. This.
And that's
Really have more.
This is part of it. So that's 4, 5, 6, 7, which makes it 8, and then you have
Oh,
9. So I don't have 10, 11, 12, or 13. I have 14, I don't have 15.
It's like you're
14, 15 on a line. So you can take that out.
Oh, yeah, if you take those lines, maybe.
So
For everything.
these are all the worksheets, and then there's this is part of that.
I love taking derivatives now.
That's something else. This is from worksheet 2. That doesn't get that. Yes, please. If you don't have your calculator, please go get it.
I'm like, always, I love that.
So you have 1, 2, 3, 4, 5, 6, 7. So right now you're gonna set a
I love it.
and then this one,
I'm excited.
well, it's up to you.
Okay. No, if you like that,
I mean,
I'll give you a pass. Give me a second. You guys, I think, should be able to start checking your homework.
He helped you guys out so much.
And I need to have 1 through 9, and you're gonna say,
And I had like, oh, come.
5, 6,
I always saw
Gosh, now I'm telling you that I'm really gonna study is just last year, and I'm really excited. This is gonna be so great.
Mine's
And they should all have sentences, which they do, and I think all of them. You have your and then we did 14, 16, and 2 there. 14, 16, and 2 C. So you have 3 A and B, 11, 12, 10, 11, 12, 13, 8. So right now, if you just do those, you get 20, 19, 18, 17, 16, 14. You'd have a 13 out of 20. I have a 7 out of 10. So I need those. Technically, by tomorrow. Now I have to give you that. Right. Yes, yes, you may go.
Yeah.
But what you know, I mean, try to listen to what you missed.
I'm so excited. No, you're not.
Okay, you guys should be checking your homework, please.
Mrs. Taylor,
Yes, dear.
where should I set
You can just set them right up here. If you don't have your highlighter, you need to grab it out of your cup, or you need to grab one of these. I don't really want you taking these every day. I want you to take one and set it back. All right, next. To what is it called again? Wait, hold on. That's the pass. Okay, so now your calculator will have everything in it for today. All right, Patrick, did you bring your calculator today? We were betting on you first loss. I bet against you, they bet for you.
That's fair, I mean,
All right. Did you get the list off of Courtney's calculator last night?
no, we both forgot it.
Oh, that's my responsibility?
No, I'm just saying we both forgot. That's my
Okay.
fault, but we both did.
It's Patrick's fault. I'm just gonna put it out there.
No, I know, it's totally my fault,
Okay.
but we did both.
No, it's not my responsibility to remember, so I just do forget.
Exactly.
Thank you.
All right, is there an open desk? I feel a little. I guess you have, probably from the high chair, huh? If you would prefer to sit like right here. All right, does everybody else have their calculator? Does everybody have a highlighter? Okay. If you need to get it out of the cup, get it out of the cup. Good morning, Will and Talia. Sorry, we were just taking care of a little situation here. We're gonna check our homework. I have been told that somehow I did not get number 12 uncovered. And it's still covered up. So here is, oh, and I better stop the screencastifier. This is gonna be a 2-hour video or longer, so give me a second. I'm going to